Okay, so in the previous video, we were working with the inverse norm function of the calculator where they gave you a percent or percentile rank, and we were trying to calculate a z-score. Well, here we're going to not just calculate a z-score, we're going to calculate actual values. This requires a little bit more work shown, but we're going to go to the same place on the calculator, and it's actually pretty nice. It works pretty well. So here we go. A student claimed to have scored at the 99th percentile. What is the score? But we know a little bit more than that. We know that the population is normal with the mean of standard and standard deviation of 7. All right. So I'm going to start off by going, you know what? Let's draw our picture. So my picture looks like this. Mean is 79. U 79. Standard deviation is 7. They scored at the 99th percentile. Well, that means, and I gave a percentile rank, so I'm starting at negative infinity and going up. I'm looking for this value, all right? And I know that this area is 0.99. So we need to do a couple things here. First off, they told me it's normal, so z equals x minus mu over sigma. So I want the probability that z is less than x minus mu, x minus 79 over our standard deviation of 7. Well, I'm missing two things here. I'm missing a z value and I'm missing an x value. And I should say 79. I know it looks horrible. I just don't want to go back and read the report. All right. So I'm stuck because I'm missing two things. Well, in comes the inverse norm function, and I can use that to calculate that z value. So to calculate that z value, I'm going to go second vars, inverse norm, 0.99. Whenever we're doing an inverse norm, whenever we're doing a z-score, it's mean of 0, standard deviation of 1. And I end up getting 2.326. So I now have z equals 2.326 equals x minus 79 over 7. Well, I need to show this z-score, so I need to do that step. But the calculator's smart. So now that I've shown this, there's one other thing I can do that's really nice. I can either multiply that out by algebra, or I can go second vars, inverse norm, 0.99, and I can actually use the actual values. So 79 and 7. And I end up getting 95.2844. So my answer to that problem is 95.2844. You need to show, I need to see that z-score. So we need that z-score right there. Okay, so z or x equals, the x value that we're looking for is 95.2844. And over here, if I were to add it to this graph, that would be right here, 95.2844. So 99% of the population is below 95. And that makes sense because 95 is well above the 79. All right, next problem. A student claimed to score at the 25th percentile. So what is their score? All right, so we go back to our picture. That's not a very good graph, but that's okay. It is what it is. This right here is 0.25. And we now have a z-score, a mean of 79, u is 79, and our standard deviation is 7. Z equals x minus mu over sigma. Because they told me it's normal, I plug in what I have. And what I have is a mean and a standard deviation of 7. And we're looking for this x value that we know, but I don't have a z, but I can get that z by doing an inverse norm of 0.25. So second vars, inverse norm, 0.25. mean of 0, standard deviation of 1, and I get negative 0.6744. All right, now let's go back and rerun it. Second vars, inverse norm, and now we're actually going to use the actual values. And the actual values were mean of 79, standard deviation of 7, and I get 74.27. So our x value is 74.27, and that was the actual problem that they were looking for. And if we look at our graph, that sort of makes sense because it's below the average. This is 50% is here, so maybe 25% is right there. Okay, so that takes care of that problem. The next one, what the upper 10% of students are associated with the scores above. So when I go ahead and do this value right here, we're looking for this 10%. We still have our mean of 79, and we're looking for this x value. Mean of 79, standard deviation of 7, z equals x minus mu over sigma, plug in what we have. Well, what I have is I know my mean. My mean is 79, and I know my standard deviation is 7. We're looking for that x, but I don't have my z, but I can get that by going second vars, inverse norm. Now, remember the calculator works from left to right, and since it does that, this is going to be 1 minus 0.10, so we're looking for 0.90. So the area is 0.90. I need that z-score. So this is going to be 1.28. Now, technically, it looks like we're solving this by algebra. We don't even have to. The calculator will do it for us. So second vars, inverse norm, and 79 and 7. So we end up with 87.97. Oops, 87.97. So this value right here is 87.97. And we can see that it's pretty high above the mean. Once again, I have to have that z-score. So get in the habit of writing the z-score. They're really picky about that, even though the calculator is doing it pretty nicely behind the scenes. All right. So then it asks for the lower 10%. Right. So the lower 10% is over here, 0.10. We're looking for this x. This is 79, mean of 79, standard deviation of 7. Z equals x minus mu over sigma. And x minus 79 over 7. Second var is inverse norm. .10, mean of 0, standard deviation of 1, because we're working with a z-score, and we get negative 1.28. All right. Rerunning it, but this time with the actual values. Second var is inverse norm, 79 and 7. And we end up getting 70. And that makes sense because 70 is a pretty good bit below the actual value. All right. So our x value in this case is 70. This was the 5s for work shown. And finally, 80% of the students scored above what? So they say 80% scored above what? They're looking for a value. And it's like, oh, the 80% happens to be above it. So that lets me know that I should be going like this. And just getting a visit from one of the cats in the house. So hopefully that won't make a mess. Anyway, our mean is 79. And we're looking at 0.80, and we're looking for our x right there. Okay, So the calculator works from left to right. So this area is 0.20. Z equals X minus mu over sigma. This lets me know what I have and what I don't have. So this is minus 79 over 7. We know we're looking for X. So I need to calculate my Z because I don't have that. So I go second vars, inverse norm, 0.20. Mean of 0, standard deviation of 1 because we're working for a Z-score, and I get negative 0.84. And again, I should be writing it out to 4 decimal places, but I'm just trying to keep it quick for the video. Then I want to do the actual value in second vars, inverse norm. And the mean is 79 and the standard deviation is 7. So this value is 73 and 80. So what that means is 83% of the, or 80% of the students scored above a 73.1086. All right. Thank you. Hope that worked.